everyone. You are watching my YouTube channel Chemistry by Sadhan, where my name is Sad, and we are going to discuss another challenging and harder question from the past paper. This is from AQA A-level chemistry. This question is from thermodynamics, and you guys know about feasibility of reaction, Gibbs free energy. This question is related to that stuff. Let's see how can I make this question easy. This question has three parts, but I will focus on the part C. In the part A, they are saying explain why the standard entropy value for carbon dioxide is greater than that of carbon. You can read the data here. Data is given in the table. This is the reaction. You guys can see the carbon dioxide. This is in the form of gas, while the carbon, this is in the form of solid. So entropy of gas is always greater because in a gas, the particles are in a disordered arrangement. So you have to put these things here. You have to write down these things here. State the temperature at which temperature entropy, standard entropy of aluminum is 0 joule per Kelvin per mole. So this is 0 Kelvin temperature if I am not wrong. Now I want to focus more on part C. So let's see what isn't exactly in part C. So they are asking in part C to find minimum temperature in Kelvin. Use the equation and the data in the table above to calculate the minimum temperature. Remember, the equation is delta G is equals to delta H minus T delta S. And when we have to find temperature, we put delta G is equals to 0. So delta G is 0, delta H minus T delta S. And now when I bring minus T delta S, it would be plus T delta S. When I bring minus T delta S to the other side of equality, it would be plus T delta S. I have to divide delta S here, so that I can separate T. It would be now, the equation would have this form. So guys, if I can get the value of delta H, if I can get the value of delta S, then obviously it's quite easy for me to find T. Let's see, how can I find delta S and delta H? So I am going to the back, this page, because data is given in this page. The equation is T is equals to delta H upon delta S. Delta S is entropy change, entropy of product minus sum of entropy of reactant. So these are the product, you guys know. These are the reactant. So entropy of product is aluminium. Aluminium entropy is 28, but there is 4 moles, so I need to multiply this 4. Similarly, entropy of carbon dioxide is 214, but I need to multiply this with 3 because there is 3 moles. When I multiply by using calculator and I add, it will be in my calculator 754. Similarly, entropy of reactants is 51 times 2 because Al2O3, this is 2 moles. For carbon, I need to put 6 here and I have to multiply with this 3 because there is 3 mole carbon. This is 120. So 754 minus 120, it would be 634. So this is the entropy and I need to put a correct unit as well. Entropy is in, you see this is joule. So this is joule per Kelvin per mole. Joule per Kelvin per mole. Now it will divide this by 1000. So when I divide this by 1000, it would be now 0.634 kilojoule per Kelvin per mole. Similarly, guys, now I am going to find delta S and I have two different ways to find delta S. Can you name those ways? One is the simple way, other is to make thermochemical cycle. I am going to use a complicated way, that is thermochemical cycle. Al2O3 plus 3 carbon for aluminium plus 3 mole carbon dioxide. Enthalpy of information is given here. So it means the constituent elements for Al2O3 is aluminium and oxygen and carbon. So enthalpy of formation of aluminium oxide is given here. But guys, here I am going to break aluminium oxide into its constituent element. So what I do, I just reverse the sign. I will put as enthalpy of a formation, I will put here uh, I will put here a the same value with opposite sign because I am not making Al2O3. I am dissociating, breaking Al2O3. So I'm gonna put plus 1,669. So when I put like this, I need to multiply this with 2 as well because this is 2 and I'm breaking 2 moles. Similarly, for carbon, this is 0. That is our good luck. For aluminium, this is 0. But for carbon dioxide, this is 394. I need to multiply this with 3. And I put 3 here to make it balance. I put 4 here to make it balance. And I need to put something here. 3, yes, to make it balance. So minus 394 times 3, it would be minus 1182. So I have to find this enthalpy. This delta H is equals to, say this is delta H1, say this is delta H2. So when I multiply these values, I will be getting plus 338. You see why I'm putting plus 1669? Because this is enthalpy of a formation of Al2O3. But I am not forming Al2O3 here. I am breaking Al2O3 into its constituent element. So I just need to reverse that sign. So plus 338 minus 1182. That will be 2156 kilojoule per mole. So here I gonna put 2156, here I gonna put 0.634. So when I solve this, I will be getting answer. This is my temperature in Kelvin. So this is how I solve this question. If you guys want to enjoy my one-on-one tutoring sessions, don't hesitate to contact me. And I request do share this video with your class fellows, with your friends. Have a nice day. Enjoy.